Hello friends. So in this video, I'll discuss the problem that was given in the previous lecture. So it is called as a tutorial 1. So two problems were given. Maybe this solution video can extend to second video as well. That's why I'm saying it's a part 1. Okay. So this will be the way of this particular series on this basic electrical circuits. We'll be doing some lectures, and after that, two, three questions for the homework, and after that, the solutions that I call the tutorial, and the solution of previous class homework question will be provided in that. Okay. So the question was a simple RC question, what I told in the previous classes, but only the modification is here. Instead of giving any input, what I've given here, okay. So directly saying that my input is pulse or what I say step, I have given a switch here. So the purpose of switch here is just to apply the input that is a 5 volt when I require it. Okay. So usually this switch is used a lot in such circuits where we'll also know that in the future with the switch capacitor circuits we'll see it a lot. Okay. So switch is just doing what it is doing when it is connected to R. It is just giving the 5 volt there, and when it is open, so no 5 volt is there. Okay, so this thing I can say, but now point here comes the when the switch is open, my R is floating, so I will not concern about that. Okay, so we'll see the question accordingly what it is given here. So what is given? It is given that the switch is closed for t less than 1 second. T less than 1 second. Uh, Switch closed for t less than 1 second. Okay, so let us consider that the switch is closed at t equal to 0 positive, or I can say 0. What it meant to say, so before this node was floating, and when this switch means at t equal to 0, 5 volt is connected here. So more like we can say it is something like that. Okay, so I should say less than 1 sec, better to say. Okay, so switch is closed at t equal to 0. It means we are applying a 5 volt signal across my RC circuit. Okay, that is the value is also given for the R and C. Here I am simply applying a 5 volt. So this way we can think it before the node was floating or whatever it was. I'll consider that no voltage was there, and at t equal to 0, the voltage of 5 volt is applied. Okay. So if it is closed till 1 second, I consider here, or better to say here, t equal to 1 sec. Let I should take the exact number. That is the 1 second. Okay. So if my means switch is closed for the 1 second, then what will happen? Okay. First, I should see here the time constant is required. So the single circuit means single RC elements are there. The time constant is not a problem. So tau is nothing but RC, which is equal to 1 second. Okay. So my switch is also closed for means 1 second, or here I mentioned the less than 1 second. I'll clear slowly. Okay. So we have discussed in the previous lectures that what should be the response when a 5 volt is suddenly applied here, and after that it should charge. Okay, the simple point is that my capacitor should charge so that there is some voltage accumulating here. So again, I will not tell exactly the what should be the nature and all, because I already told this about these things in detail in the previous videos. Okay, so what will happen? My capacitor will start charging. So as we know, what is the initial charge of the capacitor, or we say the initial current across the capacitor? What? Simply, I will say that initially when this voltage is applied, suddenly I closed the switch, so the 5 volt is suddenly applied. Okay, so capacitor is shorted. Sudden application of 5 volt simply means we are applying the signal at very high frequency. Okay, so we can consider it as the kind of step signal. So after that, what is happening? We'll see here that what the IC0. Okay. So IC0 is simply because my capacitor I'm considering to be shorted. So 5 volt minus capacitor voltage is nothing but output voltage by R. So it is 5 by R is 1 ohm here. So it is means 5 volt. Sorry, 5 ampere. This is my initial current. And this initial current will charge. So initial slope we also know. Slope at t equal to 0 positive, that I should say 0 positive, is equal to what? Simple, this current by the capacitor value. Capacitor value is also 1 farad. So it is 5 ampere per farad. This is the slope. Okay, initial slope. So we'll simply see the nature of the output voltage is with respect to time. It is simply the initial slope is there and it will follow the exponential that we all know. Okay, so ideally when it should settle at a very large time. At tau is given as like what do you say, 1 sec. So usually we consider that at 4 tau it will settle to 4 to 5 tau. So it means 4 to 5 seconds it will be settled within the accuracy of 2% or 1%, what we say. So 4 to 5 tau is the settling time. Okay, so this is the settling time. It will take 4 to 5 seconds. But what I'm asking the V out value at 2.5 seconds. So what it means to say what is happening? Actually, my time constant is 1 second here, and I am also opening my switch at 1 second. Okay, so better to say it is at t equal to 1 second. So somewhere here I have reached. Okay, somewhere here we are reached, and after that we are opening the switch. So what will happen after the opening? So first we have seen this is a tau charging. Okay, I mentioned tau charging. That is the time constant for the charging of this capacitor. The capacitor will charge in this way, and if it stays for the infinite time, it will reach to 5 volt. But actually, it is not happening. At t equal to 1 second, it is opening, so it is nothing but a tau only. It is nothing but a tau only. So, what is the value we have reached till this point? We know that the tau is nothing but a 70 point some nearly 70% of, or not exactly 70, but yeah, we'll see. So the tau is the value. Okay, so your 1 second is equal to tau, so we have reached some value here. Okay, and after that my switch is open, so we have to see what is the discharging time constant and how it is discharging. Actually, so charging we have seen here, it is simply following the exponential nature, and it should settle at around 4 or 5 seconds to the 5 volt value, but we are not giving this much time to my circuit so that the output voltage of the capacitor voltage can be settled to the 5 volt. Okay, so what will happen exactly in the when switch is open? Let's say at t equal to 1 second, or I should say 1 second plus, what is happening? My switch is again open. So this is my R. Now this node is floating. This is my C. This is the V out. This is the IC. Okay. So what is happening at t equal to, now circuit is open. So obviously the current is zero. IC is zero. But what mean to say? IC is zero simply means now capacitor is not charging. Okay. IC simply means capacitor neither charging nor discharging. Okay. So simply means circuit is open, discharging, charging. Okay. And it is discharging. Simply the circuit is open, so no current will flow across it. It will not discharge. So simply I mean to say means if I see the tau discharging, what it comes to, it should come to R out, or I should say R effective times C. So what is the R out? Actually, the circuit is open, so I will say it's a mean to say infinite. Okay, so R out is what? Infinite. So simply my discharging time constant is infinite. So it will discharge in a very long time, or mean to say simply infinite time it will not discharge. The point is simple that it will not discharge. It will not simply means it will hold its value forever. Okay, so it will hold its value forever. So what was happening there? It has reached to some value, which is nothing but a value at t equal to 1 second, which is also the tau. T. This is my VC, or I should say V out. They are same. After that, it will hold that value only. So it will hold that value for the forever time. Okay, this value is C. So we know the a tau was the value, but even we'll approach through the equation so that we can find the exact solution. Okay, so what is the charging equation of the capacitor? The one fundamental rule that we know for the first order system is what? What is VC infinite plus VC 0 positive minus VC infinite e to the power minus t by tau. So in this equation, we are considering that my capacitor is charging forever. Okay. So consideration is that cap is charging for infinite time. Okay. So we will simply write what should be the expected charging equation, because we are not concerned about that switch is open in between for this equation. Okay. So what should be the infinite value here? We see infinite simply the value that should be if my switch is closed forever, or if my voltage applied forever after t equal to 0. Okay, so then VC infinite should be ideally is 5 volt, and what is the 0 positive? It is 0, and after that is a minus 5 e to the minus t by, that is tau c. Okay, so it comes to be 5 1 minus e to the power minus t by tau c. That is the general equation, charging equation. So what is the capacitor voltage? It is nothing but 5 1 minus e to the power minus t by tau charging is of 1 second. Okay, so simply I can write it to be 5 0 minus t. Okay, so what is the value of this voltage at 1 second? So it is nothing but tau itself. So we will see 5 1 minus e to the power minus 1. Okay, so this value comes to be what? We will see it is nothing but it comes to be 63 point some percent. Okay, what it comes to be exactly, it is yeah, it is nothing but a 60, actually this, you know, this factor comes to be 63.2% of the final value, or I'll say it comes to be simply times 0.632. Okay, so this is the value at t equal to tau or t equal to 1 second, which comes to be 3.16 volt. Okay, so my capacitor is charged to this value, and after that this is holding the value. Okay, so it is holding the value. So this is my 1 second, and till this time my value reached to 3.16 volt, which is hold forever, because there is no discharging path for the capacitor voltage. Okay, it will hold forever. Now what to speak of the current? So we have seen that initial current of the capacitor was what? It was simply the 5 ampere, and after that when my capacitor was charging slowly, this current was reducing. Let's say at some another instant, which I call t naught, which is greater than, just greater than t 0 positive, is some, let's say, 4 ampere. So again we will see the discussion we have seen a lot. It will follow some discharging exponential relation, but what should be that? It should only follow till the I mean to say till the time of t equal to 1. This relation should be followed, and after that what will happen at t equal to 0, sorry, t equal to 1? The circuit is is open suddenly. So this is my capacitor. So what is happening at t equal to 1? My this circuit is open. So suddenly this current whatever built during the discharging phenomenon, it is now suddenly reached to 0. It is suddenly reaching to 0 at t equal to 1. Okay, because circuit is open, so no current will flow. So what should be the, ideally we have seen that when my capacitor is charging forever, this current comes from what we should say 5 ampere to 0 ampere. It should come like this, but what is happening at somewhere we are interrupting it at 1 sec. So it should do what? It should start with this value, the 5 ampere, the maximum value. This is equal to IC, and after that it should reach somewhere here. which I call the value at 1 sec, and after that it is suddenly reaching to 0. So we can like it will suddenly reach to 0. So after this point, it is suddenly reaching to 0 and staying for 0 forever. So this is the exactly current plot. Okay, this is the current plot. This is the voltage plot. Because when we see the general equation of the capacitor charging and what it comes to be, it is nothing but 1 upon C it dt plus some Vc, what do you mean to say, a 0 negative, or and say at any time that I should say, or time instant. So when the current is zero, no, this term will be zero, but it will stay. This is nothing but a value. In our case, this is nothing but a value till t equal to 1 negative instead of 0 negative. So okay, so it was reached to, so it reached to 3.4 volt. So it means this term, the integral term can be zero for this capacitor voltage, but this VC zero or VC1 negative will stay forever because now IT is existing no more. Okay, if IT is not existing, the capacitor will not care about it. The integral term will be zero, but the whatever the voltage he is stored till that point, or means the capacitor has stored till that point, will remain there only. Okay, and forever. So I think we have covered the simple things here, and I started the discussion in a very gradual fashion. We should consider about the equation, this, and the only point that I want to make here, even what is happening in between, don't worry about that. Okay, whether my switch is opening or closing in between, first write what should be the general equation. Okay, so I'll recommend here the point here is always write most general equation for the capacitor, most general equation. After that, put time instance. After that, put time instance. Wherever we are opening the switch or closing the switch, whatever the action is happening between 0 to infinite time, just put that particular thing there in the equation. So first we have to write the equation for, by considering that we are simply applying a voltage till the time infinite. And so what is the general equation? It's nothing but a 5, 1 minus e to the power minus t by tau. Okay, so this is the very basic discussion. And the next problem, that is problem number 2 for the previous class, we'll discuss in the next video, and that will be titled as tutorial 1 and about the part 2. Okay, so for every means class problem, when I'll give the problem, it will be solved in the next tutorial, and that tutorial number can have 3 4 problems. Then it will be divided into part 1, part 2, part 3. So fresh tutorial for few class then question. Okay, so few class followed by like question, and this question solution in the tutorial video, and then we'll see the lecture after some tutorial discussion. Okay, so till the previous video we have discussed the 5 lectures. Now it is a tutorial first, and the next video will be the lecture 6. Oh, okay, first I have to solve this properly, means both the solutions. So after tutorial 1 is completed, we'll go to the lecture number 6. Okay, so this is enough for this video. Thank you.